Hello, welcome to our first lecture. Today we'll be dealing with fluids. Now, what are fluids? Fluid is anything that takes the shape of its container. I'll write that down. Anything that takes the shape of its container. Now that's what a fluid is. Anything that takes the shape of its container. Now, fluids are actually of two types. When we talk about fluids, we mainly think about two types. One, liquids. The other one, gases, which is quite a common knowledge for many people. Now, what is the difference between a liquid and a gas? Why? We could have put them in the same group. What is the difference between them? The difference is that a liquid is something which is incompressible. A liquid is incompressible. Whereas, what about a gas? It is not incompressible, but it is compressible. Gases are compressible. As you know, many gases are compressible. You can squeeze a balloon filled with air because it's compressible. Whereas you cannot squeeze a balloon filled with water much, or you cannot squeeze it. Okay, now since you have got an idea of fluids, we'll be deriving an equation for pressure related to fluids, related to water actually. Now I'll be removing this off. Okay, now I'm going to draw a special type of a container which will best describe what I'm about to derive into. Okay, sorry, that's not what I meant. Sorry about that. So this is a container. Consider this as a container, and the area of this circular portion over here, we'll assume it as A1, and this area, the area of the circular end, as A2. Now consider that we have some liquid, not water, any liquid, up to a level over here and over here too. I'm repeating, it's not water, any liquid. So I'll give it any other color, green. I don't know what kind of a liquid that signifies. Anyway, let it be. Now assume that we have a piston over here. Piston. Assume that I have a piston. Let me try this. Yes, I have a piston over here. Right? A piston. Now imagine that the piston was, the water level was actually from here, and the piston pushed it downwards. It covered a distance of, let's assume it as d1. Okay, and let us also assume that before we pushed the piston, the water level was this much, and it increased a distance d2, or increased a height d2. Now, as you know, as you can see that this volume of water compressed or pushed by the piston, let it be V1, will be equal to this volume raised over here. Let it be V2. Now just I told you before what that liquids are incompressible. Therefore we can also say that V1 is equal to V2, can't we? Now what is this V1? As you know, volume of anything is equal to the base area into height. So this base area over here is A1 and the height is D1, right? The height pushed by the piston is D1. D1 into area is the volume. So volume 1 is equal to D1 into A1, or A1 into D1, which is equal to V2, right? And V2 is V2. V2 is equal to similarly base area into height, D2 into A2. Okay. Now we actually don't need this equation for some time, so we'll keep it in a box. Now another equation. We know that the work done over here, suppose a work I is done over here, a work in is done over here, will always be equal to a work 2 over here, right? This is because the conservation of energy, and the energy is neither created nor lost. Therefore the amount of work done will always be equal to the work done over here. So W1 is equal to W2. Now what is the formula for work? Work is equal to force into displacement, right? I hope you have learned that. Now what is W1? I'll do it in another color. W1 is equal to, let's call it F1, since the force for W2 will be different. F1 into D1, right? So we have a force F1 which does a work of Wi, right, which is equal to, from here we also have, let's assume that a force F2 does a work of W2, F2 into D2, right? So I'll put that in a box. Yes. Now these are the main equations we need to derive this thing I'm going to do. So what can we, so first of all I take this, let me change to, I take this equation and I'll write it once more. F1 D1 is equal to F2 D2. Yes, you know how that comes out. So what I'm about to do is something crazy. I divide and multiply the left hand side with A1. A1. I hope you have understood what I've done over here. Like, I can cancel this A1 and this A1, so there's no change in the equation actually. I've simply divided it and multiplied it by A1. And similarly I'll divide and multiply with A2 over here. I've divided and multiplied with A2. See? Now comes the substitution part. Let me ask you something. What is this? And what is this? d1 into a1, d2 into a2, and I hope you've recognized it. It kind of looks similar to this thing in the second thing we put in a box, and it also states that this is equal to this, right? v1 is equal to v2, therefore d1 into a1 is equal to d2 into a2. Therefore we can cancel out these two, right? So we cancel these two. Now I need some space. Let me clear this figure out, or I'll clear this equation out. Okay, so we have space. So from this, sorry, wrong tool. From this we have f1 by a1 equal to f2 by a2. Alright, now what is the equation for pressure? As you know, pressure experienced is equal to force by area, and I'm sure most of you who are watching this, who understood this lecture till now, knows this equation very much. So let's consider a pressure P1, which is F1 by A1, is equal to P2. Now that is the equation what we have derived, right? That is the equation what we have derived, right? This is the equation which we are derived into from these two equations, and this, sorry, from this and from this. So now since we have got an equation, what does this mean? This simply means that, let me rub off this portion. Okay, this equation simply means that the pressure exerted down towards this, by this prism towards this liquid will be equal to the pressure exerted here, that is P2, and this is P1. So that is what we can infer from this equation. So therefore, if we apply a pressure over here, the same pressure will be applied over here, right? So I hope you've understood what I've derived and what I've concluded from that. Catch you up in the next lecture. Thank you.